PPA assignment 8, we're nearly there. CW9 is released now, so that's one more task after that, which will be kind of a bit of a revision task. And then the end of term is upon us. So this week's feedback video is on assignment 8. Again, very important that you watch these videos and use them as your feedback and learn how to improve, not just this semester, but also next semester and going forward as programmers. As always, engage with me and send me critique or criticisms of what you've seen, a critique of what you've seen, criticisms of what you've seen, and we can chat about what's going on in these videos. Assignment 8. After obtaining a fortune of gold coins from their treasure hunt, our pirate has now docked at a port and is headed into town to purchase products from a shop. Once inside the shop, the customer, pirate I guess, can view the products in stock at the shop, add products to their shopping basket, or remove products from their shopping basket. Finally, they can purchase all the products in their basket, which transfers the money to the shop and then transfers ownership of the products to the customer. So, perhaps it's worth saying a bit about the brief. So, when we first rolled the brief out, it was kind of in one form, and then we noticed there was a little bit of a logical gap in it, so we revised it a little bit. Whether you submitted a version based upon the very a version of a solution based upon the very first version that was released or the updated version doesn't matter. If you happen to access the brief and kind of print it in the first few hours, these updates were made literally within hours. But if you accessed it straight away and happened to print it, and we're working to a version here that talked about shopping lists rather than baskets, that's absolutely fine. It would be very unfair of us to alter the brief and have that affect you in any way. So if you worked to the version of the brief that was available when it was first out, that's fine, no problem with that. Or if you worked to the more updated version, that's fine too. So in general, these briefs, we do think them through before we release them, so there's never any huge issues with them. It's just every so often we like to update kind of, typically what it is like one or two things. It's either typos or just extra clarification. But in the case of CW8, we did switch things around a little bit more extensively, which again I think is really in your benefit, so you get the most logical solution that you can. But again, if you built the original version, that's fine too. But so we would always encourage you to always view the most recent version of the brief online. So for, I guess this semester's nearly over now, but next semester definitely always try and get the latest brief from Keats and work from there. But of course, if you work with a version that was shopping lists, that's also absolutely fine. It would be unfair if that wasn't the case. But I'm going to work with a version with shopping baskets. So we're asked to model this scenario with the pirate who's coming from the previous assignment. He's docked. Nice to see some continuity here, which we'll talk about again in a second. He's now docked and he wants to spend the money that he's got from these islands. So there's a nice bit of continuity going on here. Another bit of continuity is 1.1, so model this scenario based on the following requirements. All financial transactions use gold coins specified in the previous coursework. So again, we really want to emphasize just how important the feedback videos are for you. So here we gave you a free mark if you were able to go back and look at that feedback video and find the correct implementation of the gold coin class. So again, just to re-emphasize how important it was, if you used your own gold coin class and it happened to be wrong, then unfortunately that will be another mark lost. So the idea here was to really see the importance of of going back to these feedback videos and seeing actually more tangibly, as in with a direct impact on your future ability to complete the briefs that follow, to see what an impact these feedback videos have. Okay, so a free mark there if you went back and watched the video. Unfortunately, a mark lost if you used your previous gold coin class and it happened to be incorrect. But here again, just to emphasize to you in a really tangible way just how important these feedback videos are. So I have gold coin already here waiting for me from the previous assignment. Again, go back to CW7 video. I'll link to it again in the little eye in the top right of this video. Watch that, engage with that. Lots of people are telling me that was an extremely useful video, if not the most useful video they've seen, because one of the great things about having more complex assignments is it gives you an opportunity to explore way more language features. So it's probably the case with CW9, which is also a little bit more complex, but hopefully a lot shorter than CW7, so that you still have a bit of time to do whatever revision you need to do. Although on that topic, remember, the best way to revise for the class test is these assignments, so again, ostensibly, to watch these videos. So hopefully you're here revising, which is good. So 1.1 is already done for me. 1.2, a product has a name and a price, indicating how many whole gold coins are required to be exchanged in order to purchase a product. So I need a new class product, and it has a name and a price. This should be very, very pedestrian for you. I love that word, pedestrian. And so obviously name is going to be a string, but price, maybe you'd think it was going to be a double, but no, because look, it says very carefully, indicating how many whole gold coins are required to be exchanged in order to purchase the product. So it's going to be as an integer. When we create an instance of this class, we should be able to provide values to these fields. Again, this should be very familiar now. This is talking about a constructor. So we want the name and the price of the product. Stop name equals name, stop price equals price. And as always, I'm going to jump a little bit ahead and make my main method as soon as I can, so I can use it to test what's going on, which again is always a technique I recommend you use. So shopping trip, here we go. By the way, I know that there are loads of Eclipse shortcuts I could use to help me here, but I just want you guys to see it all typed out and not to sneak ahead and use those shortcuts where possible. In fact, not to use IDEs at all until next semester, but we're nearly there. We're nearly there when the time for IDEs is upon us. Product has a name and a price, done that, indicating number of whole gold coins. We should be able to provide values to these fields when we create the class. Furthermore, there should be a default string representation of objects of this class using standard convention. Okay, so actually let's make some objects. Not public, product. And what were the products that we had? We had a diamond. Which is called diamond. And its price is 40. And we have another product. Again, this is me skipping ahead to 2.1. And then we had crown jewels equals new product. Crown jewels, they're 100, and then product silver locket, which is a new product. Silver locket. Okay. Good. So here's my 3 products. That's going to set me up for something I want to do in a second. So what we've got here, and again, this is probably the first new bit of this assignment. So remember, each assignment tests something new, which is almost always what was covered in the previous lecture. So here we're saying there should be a default string representation of objects of this class. What does this mean? Well, remember back in, I think it was the end of topic 7, we looked at noughts and crosses, and we looked at this idea that we want to be able to quickly understand some of the fields that are inside an object. So we're quite used to saying things like public string, get name, etc., etc. And then we use these methods to access information that's stored inside our objects, right? So I could say diamond.getName or something like that. But sometimes that can be a bit cumbersome. So in the case of noughts and crosses, we saw that, and moreover, we see that sometimes it's quite nice to actually have string representations of our objects, so that when we store them in something like a list or an array, like we did in noughts and crosses, we can see that printed nicely without any extra effort. So that's something that you'll also see in CW9 to kind of reinforce this idea. So there's a couple of reasons there. Again, let me say that again. So there's a couple of reasons for wanting a string representation, which means that when I print my object, I want to see some information from inside that class, mainly because it saves me having to go through the effort of using get methods, which is quite nice sometimes, and also because if I want to then store these products somewhere, say in a list, as again we'll see in this assignment and also in CW9, you get this nice string representation of an object. But of course there's a drawback in the sense that you lose the kind of fine-grained ability to select which bits that you want to be printed. If you have a whole single string representation, because as we'll see in a second, you can only have one string representation. If you have that whole single string representation, then when you print that object, when you access that string representation, then you get everything, right? You get everything that's in there, and you might not always want that to be printed out to the user. So you have to show a bit of discretion in terms of, from a design perspective, in terms of when you use toString and when you don't, and that's what we'll try and do as another part of this solution. Okay, So again, I want a string representation of this object. What does that mean? Well, we saw at the end of topic 7 in noughts and crosses, that means that we use this thing called toString, the toString method. Now, you weren't expected at the start of this coursework to know exactly what was going on here, because remember, we'd just finished topic 8 by the time you started this coursework. But now we've seen topic 9 and now we've talked about inheritance, we now know that this is actually a method that comes from this implicit object class. So we have this, I mean this is jumping ahead a bit to CW9, but we have this implicit extension here, extends object. So what we get is this method that we can override from the object class that allows us to kind of provide this string version of our objects. And because when we do system.out.println and put an object in there, Java implicitly adds this toString, we know that this is definitely going to be called when we try and print our class, because it does so, or Java does so for every object, because it's a method from the parent class. I'll say much more about this in the CW9 video. But for now, it's just this little bit of wizardry that we've added in. I wanted to explore this as early as possible, which is why we didn't wait till CW9 to show it to you. So we've got this little bit of wizardry whereby we can add this method called toString. We know it has to be called toString. We know it has to return a string, and we know that it shouldn't have any parameters for reasons that, again, will be explained in the CW9 video in more detail. But of course, we know it's because we have to match this signature. And when we match a signature of an overridden method, we can't change the return type. So we add this toString method, and what's going to effectively allow me to do is to print my object. So before we do this, let's see what happens if we don't have a toString object method. Sorry, if we did system.out.println diamond, and then I want to print my shopping trip. Sorry, run my shopping trip. Yeah. Then you can see we get this kind of odd output, which is actually the default string representation for an object. So it's the name of the class product, and 1540E whatever, which is the memory address of that object. Okay, so we have this default string representation of an object, which is product, and we want to provide a fresh default string representation of object, don't we? So we want to create our own default string representation, which is what we do when we overwrite the toString method. So if you were to print your object like this, maybe you were thinking, as you might have been with a coordinate, that printing a product should give you some more information. You'd be on the right lines. That would be quite a natural thing to try and do, I think. But we just need this extra step, which is to add this toString method in. Okay, so anything I return from this toString method will now be printed out instead when I try and print an object. So now you see it says hello, which is really nice, really neat. And again, the reasons for this are explained in topic 9 and will be covered in CW9. So again, it's about overriding, and about what Java effectively does is it adds this implicit toString method here when you run the program. So what this typically means is you don't need to add this. Again, it could actually be quite unneat, quite bad practice to actually manually add the toString in here if you don't need it, because it's just superfluous code. So no need to do toString there, because Java will implicitly add this in when it tries to get a string representation of your object. Okay, so we're going to do this. We're going to return something that we want printed instead. Okay, so a little bit of magic for now. Explained way more in CW9 in the CW9 video, but for now we know we want it. This is how this works. But we don't want to print hello, do we? We want to give some details about the about what's going on in the in the class itself. Okay, so what we're going to do is we're going to adhere to this kind of what perhaps looks quite a strange convention. Now, the purpose of this convention is to kind of mirror something called JSON, so JavaScript object notation. So let me just switch these notifications off. This kind of standard convention, as I said, might look strange, but it's supposed to kind of reflect and give you a kind of taste of what we do when we print, when we try and understand the content that's inside our objects. So again, if you're familiar with things like JSON, this is quite similar. It's a way to kind of formally represent these data structures that we have when they're in a string format. Okay, so again, not looking for a particularly user-friendly output here, looking for a technical output. Okay, so although we talk about this customer, this wasn't necessarily an assignment aimed at a particular end user. It's really just a way to explore, as we always have been, these kind of technical facets of our software, which in this case is this. idea of a technical string representation. So we want to produce something that looks a little bit like JSON output. So to do this, we're told to do this following convention. So we have class name followed by these square brackets, and we have field name equals field value. So we have basically the class name followed by a series of key value pairs, which again is very, very similar to JSON. So the idea here of giving you this string representation was to give you this flavor of what the standard string representation of objects is, which is exactly what JSON is, JavaScript object notation. Okay. So we're going to return it like this. We're going to say, well, what's our class name? It's product. Again, if you had some small permutations on this, it's not a big deal. We want to say field name equals field value. So I'm going to go ahead and say, we're going to say something like name, like this, equals name. You see, so we're just kind of building up this concatenation here. If this concatenation doesn't make sense, then have a look at it, and then we're going to say price equals price, and then there we go, right? Because we've only got this bit of information. So let's see what that looks like for our product. So product name equals diamond, and price equals 40. Okay. So this is what we have. We could try and actually include the speech marks themselves. We could do that with what we call an escape character. So again, I'm not sure if this was necessarily something we want to look at in this assignment, just a bit of trivia, I guess. If you want to use a character inside a string that would otherwise have some kind of other effect, then we use this backslash notation here, which kind of cancels out the effect that it would normally have, if that makes sense. So here, if I were to not have this, then we'd kind of end our string early and I'd get this error because it means that I'm not matching up my speech marks. But if I do this kind of backslash here, then we have this kind of, we say we want to use this character literally, right? They're called escape characters. So we escape it from the string. We basically mean that means it doesn't have an effect on the string. So we can actually get this rigid notation here. But again, I'm not sure that was exactly what was wanted here. The speech marks in the brief were just to kind of give you an idea of the fact that these were strings that were being put together. Okay, so I think this is fine. We'll just leave it at that. But just bear in mind that's what you'd do if you actually had to use speech marks inside a string. 1.3, a shop has a name and a number of collections of elements specified below for which you must select the appropriate data structure. When we create an object of this class, we should be able to specify a value for the name and the collection should be initialized. All right, so hopefully this makes sense. So very, very simple class here. Tested nicely now, so we can print products. Actually, let me just do it for crown jewels as well, so you can just see the full capabilities here of toString. So you see, it's based upon, just like any other method, it's based upon the values that are stored in fields. So toString is automatically invoked. No need to do toString. There will be some occasions when you have to do that, but not in this one. So of course, if I try and print an object, I get this default representation. Okay, so no need for toString. It's like an automatic getter, basically. But of course, again, see this drawback now. So every time I call toString, every time I try and print this object, sorry, I'm going to get both of these pieces of information, aren't I? Whereas sometimes I might just want one, right? So I might not always want to see, when I print my product, I might not always want to see the price, for example. But here, because it's inside my toString method, I will. So short of taking it out, I'm always going to see price, aren't I? So again, this is kind of toString versus get and set. If you want that kind of finer granularity of control over what you're printing, go for get and set. If you're happy just to have this default representation, which is what we call it for the string version of our objects, then we can just leave it like that. Shop has a name and a number of collections, as I've said, so let's make our shop, for which you must select the appropriate data structures, which of course was the point of this assignment, testing you on the use of different data structures, nice data structures that we saw in topic 8. So when we create an object of this class, we should be able to specify a value for the name, and the collection should be initialized. So I know a shop has a name, like this, public shop, private string name. I guess just because it's just popped into my head, someone asked me a really great question yesterday about, why are these briefs so rigid? Why are you kind of drawing us to this answer? I thought it was a really great question. I mean, I guess the ostensible kind of implication there was that they were somehow kind of squashing creativity. I mean, we're not trying to do that at all. So we're kind of just, these briefs are a bit stylized. I completely agree. They are perhaps a little too specific. But there's a couple of reasons for that, I guess. We want to draw you towards these good elements of programming practice. So we want you to follow these in kind of in quite a stylized way. Think about how one kind of group of programmers, which is the lecturers on this module, would construct their solutions. And we also just want to kind of, as I say, to give you this experience of seeing how someone else would construct a program, adhering to good practice and things like that. Okay, so it's not our intention to squash creativity here. We actually want to encourage it, and there will be some parts of each brief where you're free to kind of be creative. Again, this is not an issue. We don't do this for the automatic marker. That's really just a side issue. We will accept a range of solutions so long as they're efficient and make sense given the brief, no matter what the marker says. So again, the nature of these briefs is to kind of guide you in this way towards an efficient solution, a solution that kind of sticks to the rules that we've been taught. And of course, they're always going to be a bit stylized in the sense that we want to guide you towards looking at different parts of the syllabus. So, for example, very early on, we kind of guided you away from more advanced techniques because we wanted you to just do the basics first. And now we're kind of doing the opposite, right? We're actually forcing you towards these more advanced techniques. Okay, so they will always feel a little bit stylized, but just follow them through, I would say. Kind of just go through the kind of the motions of following this implementation just for practice for yourself. There's always a little bit of wiggle room. We're not trying to squash creativity or anything like that. There's always a bit of wiggle room here. There will be specific parts of the brief that you can be creative with. And of course we do accept permutations on the solutions. Again, regardless of what the marker says, as long as they're efficient and kind of keep up with what we're doing. And of course, I guess finally, following briefs like this will be quite the norm in industry when you're kind of given a brief either from a client directly that you're building software for, or from some kind of senior developer who's giving you his steps to follow. I'm not describing myself as a senior developer in any way, shape or form, but hopefully you can imagine that you might have to go through a similar process where you'd be given this technical specification that you need to follow and program to because someone else has made design decisions about how the program should be, or about the way in which the program should be designed so that it can fit in with other software. Okay, so that was a massive kind of aside tangent talking about that, but hopefully that makes sense. So that just struck me when I saw just how detailed these briefs can be at times. So a shop has a name. We should be able to specify that when we make the shop, and we want some data structures because again, this brief is somewhat stylistically forcing you or pushing you towards exploring these nice data structures that we looked at last time. And the collections that we want are follow. So products, which contains the products that are currently in stock and available for purchase. So we want, our shop consists of, in some respects, this list of products. Duplicates are allowed in the collection because the product deals with very few but rare and high value products. Okay, so we're told here that we want something called products. So we want some field called products. We're told that we need some collection because we want to practice these collections that we saw in topic 8. And we're told that the collection allows duplicates, right? So the collection that allows duplicates here was an array list. That's the one that we saw in the lecture. We saw that there were these other structures that didn't allow duplicates, whereas the array list will allow us to do this. And of course, we see things like sets which don't allow duplicates. So it can't be that can't be what we're looking for. Okay, so we want the array list here. Is our option here. We're not kind of we're storing single values. We want indices because we can look later on and see that we want to do things like add and remove products. So we know we have this flexibility here. So the array list is what we want here. That's what's being hinted at. Again, if you used arrays here, which you might have started doing, you probably will have quite quickly seen how we come up across these awkward issues that we saw in CW7. So we don't know how many products we're going to store in this shop, do we? I mean, we have 3 at the end, but that doesn't mean that's just one scenario, right? So we could have scenarios in the future where we want 100, 1,000, 2, 4 products. So the idea here is that if we were to stick with arrays, then we'd have again come against this issue as we did with the pirate's purse, where we didn't know how many coins the pirate was going to have, so we had to choose an arbitrarily large length, right? So here the idea was to show you that in comparison with arrays, strict arrays, these kind of native arrays, we have a lot more flexibility with an array list because, of course, we know it can change its size in this arbitrary way. So again, this course was designed to show you how much more flexibility we can get when we have these advanced data structures compared to arrays. So again, not the best solution here if you used an array here. We really want these flexible data structures that mean that we don't have to do these awkward things like supply really huge lengths for things like storing a list of products. Okay, so array list here. Remember, we have to have this diamond notation, so that in the same way that we'd write something like a product like this, if we want to use an array, where we kind of say everything inside that array is of type product. We do a similar thing with array list. We say product like this. Okay, so we're saying we're typing, is at least the vernacular that I use, we're saying we're typing the array to be a product. We're saying it's homogeneous now. We can only store products inside of this kind of flexible resizing array. All right. So array list is just a class, a library class like scanner, anything like that. So unlike arrays or strings maybe, which are kind of act like classes but aren't really, array list actually is a class. Actually is a class in this respect. So it has to be imported in the same way that scanner does. And I think, let me just cheat with my little import tool here. Yep, it comes from the package util. So the same as scanner, right? So scanner also came from util, unless I'm mistaken. Yeah, so the scanner came from util 2, I believe. Anyway, let me just check this if I can spell. Yes, indeed it did. So scanner comes from util as well. Okay, so yeah, we have our list here, array list of products. And as I said, actually let me just set my name to be equal to name, should be a familiar process here now. As it recommends in the brief itself, because these are lists, because these are array lists are objects, we're going to need to do our standard object creation process. Okay, so in exactly the same way as I'd make any objects of my own classes, or I'd make an object of the scanner class, the same is true of array lists. Yeah, so this is again this field before we do this new syntax and actually put a copy of a class inside this field. It's just an empty variable of a class type, which is array list. Even with the diamond notation, this is still an empty variable of a class type that's just going to be typed in the future to contain products. Don't be confused, just because you've written product here doesn't mean it's filled with anything. The same for arrays, right? Just because you wrote product here, remember it was going to be full of null values, as we saw with the treasure chests. Okay, so again we say new array list product because we're making an object of the array list class and storing it inside products. And of course, because this is a true class, not kind of a pseudo class like string or the arrays class, the array classes that we have this kind of construct with the opening and closing brackets here like this. Okay, and there's lots of different things that the constructors inside the array list class can do. And again, looking at the API, or the so-called API, the Java documentation can tell you more about this. All right, so we create this object of the array list class and store it inside our products, which is typed to be of array list. So again, remember this is a flexible data structure. It adds, when you add things to it, it grows, and when you take things from it, it shrinks. So if there's if we've not yet added anything to it, it's empty, right? So unlike an array, if this is an array of products which would have a fixed initial size that would then be full of nulls, here this is not the case. This is literally just empty before we actually put anything inside it. All right, so this isn't enough just because you see the product here. This isn't enough to put things in the array on 2 counts. So first of all, if we didn't do this, there would be no object in that field. And second of all, even if we do this, then the list is still empty, right? Because we've not added anything to it. So the same would be true of an array. So if you didn't do this new array with a certain length for a normal native array, then you wouldn't be able to interact with it. But of course, then once you had done this for the array, then you'd get this set of empty null values. So that's the difference there with array lists. They are literally empty. All right, so we know that we wanted an array list because duplicates are allowed, so it can't be a set. And we know we only want to store one thing at each position, so it can't be some kind of map or anything like that. Don't be confused by this very few but rare and high value. Just because things are rare and high value doesn't mean that they're necessarily unique, so we can have duplicates in this list. So this is fine to be an array list. In the shop, there's the ability to add a product using a supplied product. So basically what we're doing here is we're creating a wrapper. Effectively, this class is a wrapper class, not someone who sings, something that contains something else. It's going to kind of wrap around this array list, and we're going to kind of put this layer of abstraction against kind of interacting with this products list, which we'll see here. So we've got this idea of adding a product, which takes a supplied product and adds it to the list. Okay. Again, if I do anything here that you're not sure about, products, array list is just a class. So this add is a method of the products class, rather than doing some kind of square brackets to indicate some kind of index. We almost don't always, no longer have to deal with indices almost all the time, because ArrayList manages this process, it abstracts it for us, which is yet a really nice feature of the ArrayList data structure, right? Because whereas with an array, again, as we saw in CW7, where we'd have to manually track the next available position, when we were adding things to purses or something like that, I guess you could see product kind of like a purse. We'd have to keep some kind of track of the next available index. Whereas with the array list, this is all abstracted for us. We can just call this add method, and it automatically works out where the next free position is, which in this case is just 0 because the products was empty. Well, imagine this is the first call to add product, and this would be empty. So we can see the nice abstraction that the array lists give us, and these nice methods that we have to interact with the contents in a list, and add is the first one of those. So again, if there's something that you see that you're not sure about, look it up on the on the docs. Really good way to learn that. Have a look at what's going on. But I think it's quite intuitive here that we take a product object and we add it to our list of products. There's the ability to remove a product from the collection, which takes a supplied product, removes it from the collection, and returns a positive result if it was successfully removed. Again, it's all about looking at the API, seeing the capabilities that we have. Okay, so I know this method needs to be Boolean. I want to remove a product, so it takes a supplied product, and we say products now, right? So I've got this handy thing in Eclipse. Again, this is available online, so there's no need to have this. You can look it up online. But I can see here that from the list of methods, it's offering me automatically from the ArrayList class. I can see the second one here, remove, which has a Boolean result. And if we read this little blurb, kind of to summarize, it says it's going to remove what's in the list, the object supplied from the list. Looking in terms of object identity, that is. We looked at we did look at the end of CW9 using the equals method at how to change the notion of object identity. But for now, for this assignment, it's fine to work with object identity. So it's going to remove an instance of the same object, so the same object with this same memory location. Again, exactly what's going on with objects will become clearer next semester. But for now, if we were to create one object inside our shopping trip class, say diamond, this actual object here, pass it to shop and add it in, and then remove it, then that same object would be removed from the shopping list in this way. So what we're going to do is, again, let's go back to this mini API that's given to me here by Eclipse, and I can see actually that this remove method returns a Boolean. And what actually it's going to say there, as I started saying before, is it's going to do the removing for you and then return true or false depending on whether something has been removed. So again, what this class does is effectively wraps around the products array list. It kind of takes the methods that are already in the products list, redefines them, and just passes the same results back, or at least this remove product does. So it's a nice way to get you to explore the capabilities here of the array list class. All right, so I can do remove. It'll take a product, and now I know that this is going to return a Boolean, right? Because it told me a second ago, and if I hover here, then it says Boolean, right? So what I can actually do, and again, I saw lots of people. So again, remember these videos aren't just the solution; they're also feedback based upon what I've seen people doing during the week. Lots of people doing, if statements here, saying if, maybe they'd say do contains or something like that, and then go on and do remove, and then return true, return false. But actually, you can do this in a lot simpler way. You can just literally use the methods that you have available to you, harness their abilities to build your own functionality around. So we're doing this in kind of the simplest way by just wrapping up these calls in additional methods. But again, the idea here is just to get you to explore these nice capabilities of these data structures, of these classes, of these library classes, and what they can do for us, and how you can leverage this by looking at the API. So let's see what we want. So I'm going to create a temporary, I think, does it ask for, at some point, I guess they're just going to ask me for a toString method inside the shop, right? So I'm going to jump ahead just for the purposes of showing you what's going on with add and remove, so we can kind of confirm to ourselves what's going on, whether there's any problems. So I'm going to skip ahead quickly to 6, which says that the shop should have a default string representation which presents the name of the shop and all the products currently in stock. Alright, so I'll come back to the others in a second, but just for now, so I can quickly incrementally test add and remove product, which again is what we always suggest you do. We're going to add this toString method here like this. Same as before, same as for product, has to be in this form, and we want to return some values here. So remember, toString is just a method, right? So we can do loads of different things inside the method. We could have it as long as we want, so long as in the end what is returned is a string, because that's what's going to be printed when we try and print this object. Okay, so I saw lots of people doing different things here, lots of good things that, you know, marks-wise won't really make a difference. Lots of people were doing loops, which is nice. I want to look at what this would look like. So let's imagine we wanted to, we're asked to return the name of the shop and all the products, right? So remember, the idea is that we want to ultimately return a string in the end. So what I usually do inside these toString methods is define a string, something like toReturn, something like that. Yeah, and this is going to basically, throughout the method, I'm going to build and add things onto this this toReturn string, and then ultimately return it at the end. So what's the first thing I want to add on? Well, I want to say toReturn plus it equals name. Yeah, so I want to add on to that name. And in fact, I could just do this in one line, right? So I could say I always want my toReturn string to start with name. Then maybe I could do a nice space after it. Then what I saw lots of people doing was kind of going through the products and adding them on. Absolutely fine. So we could do something like for product in products. Remember, this is our advanced for loop. Again, this is inside the topic 7 notes. I encourage you to have a look at that. Literally just takes each item from a list or an array, anything that's a collection type or an array, and passes it into this temporary variable product that we can then do something with. So we can't typically change what's stored where inside products using this for each loop, but we can interact with the values inside the array. So we might choose to say something like toReturn plus it equals product. What this is going to do is it's going to build up this list, isn't it? So I'm going to take toReturn here, which starts just with name and then this concatenated space. I'm going to go around the loop and kind of concatenate each product onto toReturn like this. So what I'm going to end up with in the end is the name of the shop followed by the list of the products. Okay, so again, I can do as much as I want in my toString method so long as the last thing to happen, or there's this adequate return in the toString, which gets you this information back. So let's see what we can do now. Let's see if everything's all right, because we've written a reasonable amount of code. And of course, we should test things as regularly as we can. So we want to make our shop. If I could type. And we want to call it something, right? I think it's called Hidden Hideaway. Nice and piratey, which is nice. All right, and then I want to add some products to my shop. So let's imagine we say shop.addProduct, diamond. See, because add product will just accept anything of a product type, which diamond is. Let's see now what happens if I do system.out.println shop. What am I going to get in my output? You see? So here we can see I'm invoking this toString method. I've got hidden hideaway here, which is the name, which is the first thing that I put in this toReturn string. And I will loop through my products, and I added them on each time using concatenation here. Remember, this is the same as equals toReturn plus product, same as this. And each time I go around my loop and I add more information about these products on. Yeah, so again, remember, so long as the toString method returns some string in the end, I can do as much work as I want inside toString. This is kind of a self-contained loop that does this work inside it. Or the method is self-contained as well. So let's add another product before I do this printout. Let's say add product, crown jewels, print on my shop again, and you see now I get this extra information, don't I? So you can see what's happening here is, see how I'm actually concatenating with an object here? So I'm kind of, there's a nested idea of this nested toString going on, right? Because product has its own toString method, Shop now has a toString method, so if I try and add an object to a string here, this will automatically be transformed into its string representation, right? So again, no need to write toString here or anything like that. Java knows that the only way it can add an object to a string, the only way that would make sense, is if it first converts that object to a string. And how do you convert an object to a string? So how would I convert a product object here to a string? Well, I call that product's toString method, don't I? I call that object's toString method, which is why we get this built up of our to return here. We have this built up list like this, so I could make that a tiny bit more readable. You see now we have this space, and we can now see all this nice information about our shop. So this is fine, absolutely fine, but there is a shortcut, right, which is based on what I just said. So if you add something that has to have a string representation to another string, then it will automatically become a string itself if there's an intelligible way to do it. And there is actually an intelligible way to find the string version of an array list, which has actually been built for us. So you'll see that if we do name plus products, something like that, get a very, very similar effect, right? Because products itself, this library class array list, someone's implemented a nice toString method that effectively does that kind of loop, I would guess anyway, that we just did here, right? But it does it for us. You know, we do get these opening and closing square brackets, which is not always the nicest thing. You might, for example, in CW9 want to take these off somehow. But that's fine for our purposes. Again, you can see just how much shorter the code is. All right, so I'm taking a name here, which is a string. I'm taking products here, which is an array list, and I kind of, maybe through experimentation, again, maybe through reading the docs, you find that array lists have this default string representation which shows the values in each position. And because each of those values in the position are a product, which in themselves have toString methods, then we've got this nested toString effect. So I'm effectively calling toString on products. And in the same way that I did in my loop before, this is then going on and calling toString on everything in the products list. All right, so that's nice. No problem if you did the loop, but I think it's just nice to know that we have this extra efficiency here. All right, so let's try removing something. So shop.remove product, take the diamond out. And there's no diamond anymore, you see, because this is what I was saying before. So inside shop, what remove does is it finds this object, the same object. You know, there's only one new command, so there are only 3 objects at the moment, sorry, including 4, well, there are at least, sorry, there's a 4th object here, which is our shop. There are only 3 product objects. That's all the objects that are in existence. So I take one object and store it inside the products list inside shop, and then take that same object and try and remove it from the shop here, and it gets removed. Okay, let's see what would happen if we happen to create a second diamond, right? Diamond 2. They're both called diamond. They both have the name, you know, the same price, 40. What happens if I try and remove diamond 2 here? You see no effect, because there was one object was added, but then a different object was passed to it. Okay, so it's this notion of object identity, which again we started looking at in topic 9, how in this case it's fine because you can have 2 diamonds, you know, that are both diamonds and both the same. You know, we can have multiple products in a shop that are of the same type and the same cost. That's not a problem. But there might be some circumstances where we actually want different objects to be treated the same, right? So coordinates, for example, is the good thing that we looked at during the lecture. Relevant because it was covered in the coursework. So to see 2 coordinates be the same just because they're separate objects, we might want to treat them the same. This is what we started looking at with this notion of equals. And you're going to need to look at a similar thing this week for the battleships. When you look at 2 ships, how do we know that they're equivalent? And the same for 2 parts of a ship. How do we know when 2 parts are equivalent? Again, it's this idea of using equals. But again, this wasn't covered at the time of the coursework, so it wasn't really an issue. And to kind of keep things simple, we only assumed that we'd have one distinct type of each product be this kind of represented by a string. All right, so I'm going to add all my products to the pirate shop. So looking like this, and then we can print out what's in the shop. Okay, so it's nice use of a default string representation to see what's going on. So I can go back to my my shop. We can remove based upon a supplied product. And now finally it should be possible to search product, which takes a supplied product name and returns the product within that collection. So again, we're going to do this manually. Perhaps if we had the equals method at hand, we could do this in a quicker way, but we hadn't yet looked at that at the time of the coursework. So we're going to do this kind of manual search. And actually this is exactly the same as it was in CW7. So in CW7 we saw how we had a pirate search method that took a string for the name of an island. And inside the pirate class, the pirate would go through his array of islands and see when there was an object in that array that matched the supplied string, right? So it's like he's searching the map by name. Here we're going to search the product by name, aren't we? So it's a very, very similar process. So we want to return the product, because it wants to return the product with this name in the collection. So we can call it search product. It's going to take a string for the product name, and we're going to go through the list of products. So again, we know we can use this. Actually, I'm going to change this to be called name, so I don't get a local scope conflict. Inside products, and we can say if product.get. Did I have a get name? Was this something that I needed? Did I need a name? No, but I think I'm going to need it, aren't I? So again, as these briefs, if we get towards the end of term and into next semester, it's going to be a bit more about kind of understanding what methods you need to add over those things that are actually explicitly stated in the brief. Okay, so I'm going to need to understand the product name here, aren't I? So I'm going to have to say product.getName. I mean, I could rely on the equals method maybe. It's a little messy though, so I'm going to go for this direct. Actually, no, that would be tricky, wouldn't it? Because I just apply the string. No, this is the best way. So I'm going to say product.getName. Remember, dot equals. I'm still seeing people using double equals to compare strings. It makes me tear my hair out. Please don't do it like that, because your program will behave it in a really unexpected way. So product.getName equals name. If I know that that's the product that I want to find, then I can just go ahead and return that product. And again, as I said, as we get into next semester, as we start taking the training wheels off, as the Americans would say, start taking the stabilizers off, we're going to be less kind of explicit about exactly which methods we want, particularly in terms of get and set. But of course, that means there's then much more flexibility in the human marking. Okay, so especially for things like get set methods, we're going to be less explicit about what we want. But here so here, for example, it was nice just to have this little extra get name method that we want. But of course, there could be other solutions. This is just the one that feels natural to me at my time of solving it. All right, so we want to find if this product exists, so return product. Exactly the same process as we saw in the previous video for finding an island. So what do we do if we don't find a product? Well, we can't return false or anything like that. So we have to return null, right? We always have to return something. And if we don't find a product, what do we return? Well, we return null. This is a kind of, as we looked at last time, a negative result. This is the term negative result is quite a general term. Can refer to booleans, and in this case also returns to null, this negative empty result, which shows that this search has been unsuccessful. Okay, so if the product.getName equals the name, then we return the product. All right, as always, let's test it. Let's see what we get. Let's do system.out.println shop.searchProduct. We want to search for diamond. Let's see what we get. Product name, diamond. Okay, so just to confirm that this is the part that I want it to be. So found product name diamond, but if I did something like diamond, nothing. It's found null. Yeah? Simple, I think. So nothing too complex too far, just some basic getters and setters. Again, we added an extra method to help us out with some stuff. Perhaps something new with the use of an array list. These add and remove methods, quite nice, quite useful. We can build on what's given, what's told us in the API. Search is familiar because we saw it in Pirate, and again, toString. Now we're seeing the power of this and this idea that you've got this implicit toString method that already exists inside these collection classes. Right, so 3.1 is done. And it contains a coin box, which contains the gold coins that are currently in the box of money stored at the shop. The shop prefers to index each coin in their coin box. A gold coin can be deposited in the box via the ability to add gold coin. Again, some perhaps confusion at times here, but it was sufficient for this to be another array list. So there was this idea of the shop preferring to index each of their coins. That was just the references to the indices of an array list. In terms of the uniqueness of the coins and the kind of internal indexing of the coins, this is already done for us, right? So, I mean, a nice analogy, I think, is if I have £5 coins in my pocket and I take them out, then, they're going to be in a particular order in my hand, aren't they, when I count them? So maybe left to right, I might count them. So they're going to have this order, which is the same as the shop indexing the coins. You can imagine they might have little slots that they keep each gold coin in, maybe. But of course, this is separate from the identification on that coin, right? So all the pound coins, I guess, would have different serial numbers. They wouldn't be sequential or anything like that. I wouldn't order them based on those serial numbers. In fact, I wouldn't be too concerned about them. Instead, I'd have this kind of higher level ordering, which would be maybe the order in which I counted them in my hands, or in the case of the shop, the kind of order, maybe this pedantic shop keeps these coins in. Okay, so the only kind of use of gold coin here was to enable you to reuse some of your code, so you're not always doing everything from scratch, and to encourage you to look at the solution video. So no direct use again for coin number, but nice again just to see this notion of how static and non-static fields can play together. Coin box, which contains the gold coins. We've established this is going to be another array list, again now of gold coin. I'm going to call this coin box. Exactly the same process as before. Remember, it's just an empty field of a class type before I put an actual object inside it, which in this case is array list, a new array list which is of type gold coin. So we know it prefers to index the coins in the coin box. Again, a clue here, another little clue to use an array list, which is nice, really nice to kind of draw out these elements of the brief. A gold coin can be deposited into the box via the ability add gold coin. So another method, this should be quite clear. Void, not void, add gold coin. And the kind of hint here is, because there's a gold coin in this courier font in the sentence, we actually want another gold coin to add. Gold coin here like this. And this will be useful from a number of places. So when we fill the box, as we'll see later on, some people I'm sure will have done it inside the class, which isn't terrible. But given that we need this add gold coin elsewhere, as we'll see during the purchase, it probably makes sense to actually do a loop inside the main method to fill the gold coins inside the shop. So kind of slightly different from what we did in the pirate scenario, but again that's fine because this is a different application of the ideas. So we'll see this again a bit more later, but having add gold coin here, just simply take a gold coin and add it to a list, it is okay. So coin box dot add gold coin, and there we go. Yeah, so nothing new here. It's just like adding a product, except rather than adding an object of a product type, we're adding an object of a gold coin type. Same syntax, using this add method to put it into our coin box array, which again nicely doesn't have a fixed size, so we don't need to worry about indices or lengths or anything like that. Array list will just abstract this process, and keep everything tidy for us. All right. Shop. Done. A customer is the entity that can browse the shop and buy products. It has a name and a number of collections detailed below. This sounds familiar. You must identify the appropriate data structures used for each collection. When we create an instance of this class, we should be able to pass the value for the name as well as initializing the following attributes. So it's very, very, very similar to shop, I believe. So let's make our customer. Our customer has a name. Our customer has a shopping basket, which is basically just like a set of products, right? So the shop has a set of products on the shelves, you might say. The customer has a shopping basket, which is a set of products in his basket, in his temporary possession before he buys them. So we're going to say product here, shopping basket. Again, if you had shopping list here, not the end of the world. And our constructor, which we're told should take the name of the customer, should again make sure you remember to initialize these data structures. They're just classes. Again, my import java.util.ArrayList, exactly the same process again. So add to shopping basket. So just more practice at what's going on here. So exactly the same again. Look back at my full explanation of what's going on here from the previous class. So add to shopping basket. Remove from shopping basket. Of course, what this is going to do, as we'll see, is it's going to give me a true or false value if nothing is removed. Actually, we could just quickly go back and test that, right, just to make sure that we understand exactly what's going on. So what happens if I try and remove something that doesn't exist? So let's imagine if I don't add the crown jewels to my shop, but then I say shop. So I'm just jumping back here just to kind of talk about remove product again and exactly what's going on. So if I try and remove the crown jewels from my shop before or when they're not added, then what happens? We get a false, right? So again, it's the nice flexibility of remove product. So to confirm what's going on there, go back and look at the syntax, or sorry, the API entry behind remove and what's going on there. Okay, so we know that remove works in that way. So again, customer is just a case of re-implementing that as we did inside shop. So shopping basket, again, dot remove product. We know this returns a boolean, true if it's removed, false if it's not found. So we just pass that value on. We pass it on to whoever's calling this inside our class from an object of our class. And then there's the search again, isn't there? So public void search shopping basket. Oh my days, typo galore today. String name. Again, going to go through the products in our shopping basket. So product in shopping basket. And we're going to say if product.getName equals name, then we return that product. Otherwise, we return null. Yeah. Good. Okay. So that's 4.1, barring any mistakes, which was just pretty much exactly the same as 3.1. So just a nice extra way to get you to test out some of these ideas, which is nice sometimes in these assignments. You know, nothing new, but just to get you to rehearse these things, these thoughts, these ideas, these processes. So there's 4.2, owned product, which contains the products that the customer owns currently. So there's a conceptual difference, right, between owning something and having it in your basket. So I could put go into a jewelry shop and put 500 gold watches into my basket, but they might be in my basket, but Lord knows not on an academic salary, and I'm going to be able to walk out of there with those in my possession unless I steal them, which of course I wouldn't be doing. Right, so I can put as many things into my basket as I like, but I won't necessarily have the funds, again, certainly not on an academic salary, to put them into my possession, right? So there's a conceptual difference between what I have in my basket and what I own, which is what we're neatly trying to, or I think neatly trying to represent here. Okay, so owned products equals new array list products. So again, there's a conceptual difference between what's in my basket and what I own, right? So it's not in my possession. Literally, I don't own it. It's in my basket, but I don't own it until I paid for it, right? So there's a separation there between, you know, there's three states of goods, I guess, in this program so far. So they're either in the shop, so on the shelves, in the customer's basket, in which case they're not on the shelf, they're in the basket, because you can't, if there's only one thing left, as there is in this example at least, if I've taken the last jewel off the shelf and put it in my basket, it's no longer available in the shop for other people to buy. It's in my basket. And while it's in my basket, it's certainly not in my possession, right? So products can be in one of three places: in the shop, because they're yet to be bought, they're available; in the basket, which means they're removed, or they should be removed from the shop, because, you know, if I put something in my basket, I've kind of saved it until I bought it. So it's almost like online shopping, right? When you kind of reserve an item. I guess less so these days when, you know, there's literally millions of items of the same type. But you see my idea. So if I go into a shop and take the last item off the shelf, it's not available in the shop anymore. It's only available in my basket. Well, that specific product isn't, at least. And of course, just because it's in my basket, as I say, doesn't mean I own it, because I still have to pay for it. So that's the point of owned products. And a customer can add own product, which is supplied a product, and add it to this this collection again. So just some of these methods are just nice to keep your class that little bit more reusable. So add owned product, and also just to practice with, again, with these collections. So product, owned products dot add product. Cool. Purse, so another collection which contains gold coins that the current customer currently possesses. A customer can add coin which takes a supplied gold coin and adds this to the collection. So again, exactly like a treasure chest and a pirate, whereby a pirate emptied a chest of coins and put them into his purse. Similar process here, except it's kind of the other way around, right? You're going to be giving coins to the shop when you buy stuff. So two very similar collections. So a shop has a set of gold coins, because of course that's like their float. It's the money that they've made, maybe. Same for a customer, right? Which is a pirate in this case. So gold coin, purse, very similar process. Again, it's nice just to see these things side by side with CW7. So see the issues that we had with CW7, where we had to specify this huge initial value for purse. Here we don't have that problem because we have this dynamic array list structure. And of course I need to get the types right, or Java's going to complain. And of course, if you didn't some of you might have seen this. Again, these are feedback videos, not just solution videos, and some things that I saw where people getting these warnings from the compiler, maybe on Nexus. So if you ever miss out these angular brackets here, then you're going to get this warning, right, which talks about safety, because the whole point of putting these things in here is to ensure that you're explicit about the type of things that you're going to store in your collection. And when you're explicit about the type of things that you're going to store in a collection, in the same way as with an array, then you can interact with each item in that array in a consistent way. Okay, so like we saw in the very, very first example of arrays, if we know everything in our array is an integer, then we know we can kind of work with them, we can add them all up, and we can do some average calculation on that. If instead there might have been values of a different type in our array, then we can't ever get, or can't ever implement this consistent behavior, because we never quite know what we're going to get out of that array. Okay, so it's important you get a warning if you don't explicitly state that this array is only going to contain these certain things. Great. Okay, so it's pirate perf, and similar to the shop, we're going to have this method public void add coin, not add gold coin this time, just to differentiate between them as a wee favor to yourselves. So purse.add coin. Okay, so this way of now adding to a customer's perf. Alright, so the shop has one last collection, the killer collection, customer total spend, which associates the name of a customer with the total amount of gold coins that they've spent in the shop over multiple transactions. The shop has the ability to update total spend, which takes a supplied customer and an amount of coins, and updates the total spend accordingly by adding on the supplied amount of coins. Alright, so let's see what we go on here. So people struggled with this because it's something quite new. But here, think about it. So we want to associate two values together. So we want to associate a customer with the amount that they've spent. So we want sort of like a collection which has slots. You know, collections like arrays are just each slots, different slots. But this time, rather than storing one thing in each slot, we want to store two separate things in each slot. So it's like a multi-part slot to our a data structure or a multi-part index. There's two parts to each index in a way. So here we need a map, right? Because that's what a map gives us. It gives us these pairs. Effectively, it's a set of pairs, or by default. So we have these slots, each of which have two values. You can store them side by side. These key value pairings. So it's nice to be kind of, you know, this idea of mapping two things together, kind of like a dictionary, I guess. You kind of look up what's mapped to what, so you can kind of keep a record, basically. It's looking more and more like a mini database in the terms of that we have this lookup ability to find, well, here's my customer, here's their name, this is how much they've spent, okay, which is what effectively maps allow us to do. They allow us to map two bits of information together. So here's a string, and I want to associate it with something else, in this case an integer. Okay, so that's maps that what we want. So you can think about they're almost like mini objects, right? So the reason that we had objects is so that we could associate data together. So you know, we saw this idea that, you know, maybe arrays could step in instead of classes. So I think I talked about last time when we talked about did we or did we not need a map class, or we thought about what would a map class do. It would just have a series of fields that represented different islands, right? So we thought to ourselves, well, maybe we could replace that with a simple array. But now we might have a similar argument and say, well, can we have a new class for the customer spend, which would have maybe a series of fields, so customer name 1, customer spend 1, you know, a string and an integer type. So kind of associate these two things together. So we could maybe even try it. We could say customer total spend. This isn't part of the solution. I'm just talking about the need for maps. So we could have something like private string customer name 1, private in customer spend 1, private string customer name 2. You get the idea, etc. Private in customer spend 2, right? So this would be a way, again, remember objects are effectively multi-slot variables. They do allow us to associate things together in the same way that a map would do. Of course, this would get repetitive and it would be hard to kind of keep things neatly together. We could create our own pair class, couldn't we? We could create a pair class like we have done actually already, and we could create an array list of pairs. This would kind of be like a map, right? But of course, why would we do that when we have this nice expressivity that we are already given from a tree map? At least we know about it. So we can kind of just use this default data structure that's available to us. Okay, and there's also a load of benefits of when you use a map, because it has loads of nice features, like the tree map, for example, will automatically keep things in order, which is actually quite nice for talking about customers. So Lots of people asking, why didn't we talk about hash maps instead of before we talked about tree maps? Well, there's actually good reasons for that. So, or at least I'm happy that it kind of transpired in this way that we talked about the tree maps instead of hash maps because of an issue that I'll show you later on. So if you have hash maps, then you have to kind of implement equals, which we'd only looked at in CW9. So to ask you to use a hash map here without first talking about kind of what equals does and things like hash code, which I'll talk about briefly next lecture, then I could have ended up in difficult scenarios. Whereas because tree map, as we'll see later on, doesn't allow you to store objects, then it's quite nice that we kind of guided you away from storing objects in maps, which, as I say, often requires extra steps to get those maps to function correctly. Whereas because tree map doesn't even permit object storage in the first place, it just forces you down this simpler implementation. So there's always an idea, there's always a reason behind these things. So it's nice that we kind of have avoided things like hash map for now and just shown you tree map. Again, because it kind of guides you away from storing objects in maps, and when you store objects in maps, you need to do a lot more work. Implementing things like equals to get them to function properly. And again, that wasn't something that was talked about until CW9. Not CW9, topic 9. Alright, so tree map. This is what we want after that digression, that's what we want. So shop has one less collection, customer total spend. So inside shop, we want a tree map. What do we want to associate together? Well, let's start off by thinking customer, right? Because lots of people went down this route. Here's the thing, right? So lots of people also tried to put primitives inside declare primitives for their types here. That doesn't work because of the way Java's generic system is set up. So what you're doing really here is when you're typing a list is you're working with something called generics, which is a tool that Java gives you whereby you can write these general classes that present typically these kind of list structures that can be filled with any type. So you make your class generic, you kind of make it flexible, even more flexible than we've seen before, such that actual types can be replaced in that class on the fly. And that's what we do when we use this diamond notation. But generics, because of the design of the language, are only designed to work with class types. I guess that makes sense, is you'd have to make a choice between one or the other, and they chose class types because typically everything in Java, bar the primitives, is of a class type. So primitives don't work here, and you'll see that if we did something like customer total spend, like this. It would complain here. It's perhaps slightly cryptic error. So insert dimensions to complete return type, reference type. So one of the things Asad kind of focused on in topic 8 was this fact that we can't use primitives here to get around this idea that generics, which is the ability to use this diamond notation to set classes to act according to certain types. The way to get around this, what the Java guys did, maybe a little bit hacky, is they invented these wrapper classes. So versions of primitive types that are actually class types. So they're typically just the full word rather than the short word with a capital letter to indicate that it's a class. So things like Boolean. So that's why I was telling people who were using uppercase Boolean by mistake that this was a bad thing, because really you were talking about a completely different thing altogether. Okay, so we call these wrapper. I call them wrapper classes. Some people call them object types, I believe. But we call them wrapper classes because they're effectively, again, nothing to do with singing, but they kind of contain these primitive types and enable things like you to kind of type lists according to primitive types using a class type, because of course for the reasons I've described, these don't work with primitive types because the language design is only designed to use generics with class types. Okay, so you would have got an error here if you tried to use primitive types here, and it also looks a bit odd, I guess. So always remember when you're typing in these diamond notation, when you're using generics, to always make sure that it works with you work with class types, and you have these wrapper types. Just look them up for what they are. They're usually quite intuitive. So you have integer and Boolean and things like that to kind of stand in place. And of course things like double, because obviously we're used to lowercase double. Yeah, so always remember this when you're using these generic types. All these types for generics, to always use these wrapper classes. And I need my import, java.util.treemap. So I've got two types here that I'm importing from the same place, from util, where we've also seen things like scanner. There we go. So customer and double, let's see what happens. So again, have to initialize it. Customer total spend equals new tree map. I hope my reasoning for not using hash maps made sense, by the way. If it doesn't, ask me again and I can explain. Customer total spend equals new tree map. There we go. And we have our method here, which says the shop has the ability to update total spend, which takes a supplied customer and amount of coins, then updates the total spend associated with that customer's name by adding on the supplied amount of coins. Let's do this now. Let's actually make it quite straightforward at first. So let's say void update total spend. What's it supposed to take? It's supposed to take a customer and a number of coins, right? So coins. And what we're going to say is, remember, again, if you want to know how to interact with the data structure, the API is your friend. So I know customer total spend. I know that it's not add, in fact, it's put, right? So there's lots of different vernacular here for interacting with different data structures. If I want to put, I put something in a map and add something to a list. And it's put because I put it in a certain key value, right? So in at a certain key even. So here I put it in at this key and I associate this value with it. So I'm going to put my customer inside here. And I'm going to give them this value, coins that I've supplied to the method. So I want to go to my map and I want to put customer and coins. And of course this should be integer, shouldn't it? Because I was just messing around before. There we go. And there we have it. Okay, so more work to be done here. But first of all, I want to show you why, as I said earlier, we use tree maps, because it kind of guides you away from using objects in these map types until we'd fully talked about equals and all that stuff. How does tree map guide you away from using objects? Well, like this. Okay, so if I wanted to say something like shop.update total spend, so first of all, let's make my customer, call him Martin. Did he have a name? Yes. What happens if I go here and I say Martin has spent 10 coins, for example? Let's see what happens. Oh no. So some of you are coming across this, right? Looks like a bit of a cryptic error. So class cast exception customer cannot be cast to java.lang comparable. So I talked about this on the forum. What's happening here is, which I think is probably quite intuitive, so it's part of the learning associated with this assignment, is Java doesn't know how to compare customers, right? So Java knows how to compare, because of course things in the tree map are stored by key, right? Every time you put in a value to your tree map, Java's going to shuffle things around so that things are stored on the natural ordering of the keys, which in the case of things like strings means alphabetically. In the case of things like ints means kind of in a certain order, numerical order. But of course, how do you order customers? You know, what is a customer? We haven't formally defined how to compare customers, have we? We haven't done this in any certain way. We haven't said, well, you know, what's a customer defined by? Are we ordering on their name, on the things in their purse? You know, we haven't explicitly told Java what a customer is and thus how to kind of compare a customer to another one, right? Whereas with strings, this is clear. Alphabetic, with numbers, it's clear. Java knows how to compare numbers. It doesn't know how to compare customers. So this is basically what this error is telling me. You know, I can't, ostensibly here, I guess it's kind of intuitive that I cannot compare customer. Customer is not comparable. I can't transform a customer into something that can be compared because I don't know how to do it. So tree maps are kind of guiding you away from this use of objects in maps, again, because there are implications for using objects in normal maps. And for a tree map, you need to do these extra steps. So what we actually want here was this to be just be a string. Okay, and then rather than storing this, we could do customer.getName. We'll need to add on ourselves in another nice little method. Again, as the briefs get that a little bit harder, we take the training wheels off a bit, so you can now start adding some of your own get and set methods. So here we say customer.getName, so we never now end up with this issue whereby we're string, whereby we're ever running into a situation where Java doesn't know how to compare things. So Java knows how to compare strings. We're happy to store strings in our map in this way. So let's do a little bit more work now inside update total spend. We can't just put directly, right? Because if you think about it, this isn't going to update, is it? So every time I put something in a map, I'm basically putting a new value at that key. So if there was already a customer, say Martin, inside my shop, let's try this out. So inside shopping trip, let's say Martin spends 10 and then spends 20, so he should have spent 30 overall, right? So actually let's put a cheeky toString method inside here to see what's inside. Oh no, sorry, it was inside shop, wasn't it? Let's quickly add a cheeky toString method inside here. Let's remove this for now, and let's say we want to return customer total spend. Yeah, so again, we do need to write toString here because we want to say that we want to transform this to a string. So what this is going to do here is I'm just going to quickly put this to one side, the name of the product. I'm going to quickly use toString to work out what logs my shop has of the spend. So here, if I want to say Martin does spends 10 and then spends 20, it should be 30 in total, right? But at the moment it's just 20. See, because it's being overwritten each time because what I have inside shop right now for update total spend isn't quite right. So the general process I need to go through is I need to first extract what current coins there are already, and then add the new coins total to that, and put it inside. Add it onto the amount, and then update my customer total spend in that way. So what I need to do is first of all talk to the map. So I need to say customer total spend dot get, don't I? So I want to get the value that's currently stored for this name. Okay, so I'll give it a key. Remember, it's a key value pairing, so I'm kind of giving it the key to this kind of this indexing system, which is from strings to ints. So I'm saying, what integer do you have stored? What do you have associated? What do you have logged for Martin? What's his total spend? I want that back. Okay, so what I'm going to do then is I need to test it, right? Because if the value that I get is null, if there's no entry for Martin, then this is going to be a problem. Okay, let's see what I mean by that. So let's say if I do system.out.println customer total spend here, and then print this out, what am I going to get? So it's null, right? So if I never have an entry for something or for a customer inside my tree map, then it's going to be null, right? So that's going to be a problem. Yeah. So what I want to say is basically two situations. So there is already some information inside customer total spend. If there is, then I want to get the coin value out and updated. But if there isn't, then I need to just add that coin value directly in, and we'll see that more in a second. Okay, so if I do, again, another print here, then we should see that it starts off being null, right? But then it becomes 10. Okay, so we see that each time we go around this, there's two states that we can get from customer total spend. So if the customer's not found, if there's nothing in the list, then they're null. But of course, here I then come along and do put something in, so now it is found. So we can say if customer total spend equal to null, yeah, we had one too many brackets there, then I can just go ahead and do this, right? I don't need to, there's no existing entry, so I don't need to update anything. I literally just need to add in what I had before. Otherwise, we're going to say customer total spend. We don't want to put coins in directly, do we? We want to say customer total spend dot get customer dot get name dot add coins, right? See what's going on here? So what I'm saying is, if there's no entry for the current customer, so obviously the first time I talk about any customer, there's going to be no entry for them, right? So imagine my little book, my customer total spend book, which has two columns, strings on the left for customer name, and then values on the right, so we can see how much everyone's spent. That little book, those columns are going to be empty when I start, right? Especially if there's a new customer. So if there's a new customer, Martin, he's the first customer. I'm going to come through. I'm going to see, is there an entry for Martin inside this little mapping? If there isn't, then I'm going to get this null value back, right? So I'm going to try and look for Martin. If there isn't stored inside this mapping, I'm going to get a null, which means that I need to make a new entry. There's nothing to save. There's nothing to potentially overwrite. So I can just directly put into this entry Martin and the number of coins that he spent. If there is an existing entry for Martin, so say Martin linked to 10, something like that, so he spent 10 already, imagine we're on the second update total spend here, then I want to cross that 10 out and I want to add 20 to it because he's now spent 10 and 20, which is 30. So that's what I'm doing here, right? I'm saying get the existing amount, which is an integer. Here, you see this will return me an integer back. And this is going to give me 10. Imagine if I've stored 10 at the beginning, and then add 20 to it. So now we can see Martin's total spend is 30. Okay, so if there's no entry for Martin in the logs here inside customer total spend, just going to go ahead and add his details directly. Otherwise, I'm going to get what he has spent back and add the coins to it. Now notice get here returns an integer, this wrapper type, but then I can go ahead and just add it to a primitive. Again, that's a little bit of magic Java does behind the scenes called unboxing. So it's going to unbox the primitive type from inside its wrapper class here, kind of do the calculations with that with coins here, and then kind of if necessary, as you can see here, wrap it back up again. Okay, so this idea that Java kind of cheats a bit to get around this issue with generics, as I talked about lots before, by having these wrapper types, but then gets back on the ball with this idea of auto boxing. So it will box and unbox these integers from the wrapper classes. Again, no relation to singing, as necessary, because it's quite flexible and nice in that way. So lots of different things you could have done here. Again, people might prefer temporary variables, so you could declare an integer here that grabs the amount from the map, and if it's null, and then tests it. So rather than doing these three separate calls, people might see this as a little inefficient. But I prefer this over local variables. But if you wanted to have a local variable here to avoid having to go to the map each time, that's absolutely fine. I think probably the impact on efficiency here is minimal, but of course both are fine. Again, what is it? Well, it's a style choice, of course. Yeah, I think so, because you kind of lose things in terms of having extra memory allocation for storing the amount here, and gain it in terms of not having to store stuff here. But then at the same time, you have these separate accesses, don't you? You have to go to the map and get multiple times. So it's benefits and drawbacks to both. So in that case, I'd say it's a style choice. Where are we up to? So I've done total spend, which is nice. Lastly, for the shop, ensure that it can be voted to do string representation. So I did that before. I changed it temporarily, didn't I? So change it back to what it was. So name and products, and we can keep this customer total spend kind of private to the shop, which is good. So purchase products, right? So this is the tricky bit of the assignment, I would guess. So obviously each assignment has a crescendo. And this is purchase products. So we can imagine that the customer has put some items into his basket, and then he wants to go ahead and purchase them. All right, so I'm going to add in the purchase products method and then come back right at the end for the finale and finish that off, just so we can get through the user input stuff, which I know I typically rush at the end of videos. Okay, so customer, we know we're going to have this purchase products method. I'm going to stick it at the top. So public is Boolean, I think, because it confirms positive or negative whether the transaction was successful or not. So I'm going to purchase products. It has to be at a shop. Here, and crucially, we'll see this shouldn't accept a customer field. And then for now, we're just going to return true. Okay, so again, to be completed. Yeah, we're going to finish this. What's behind this interface off later. I just want to go ahead now and do the user input stuff because it's a little bit more involved for this. So I'm going to go ahead now and shelve 1.7 for now. Come back to that at the end. I'm going to finish off my shopping trip so we can at least get some interactivity going here. So what do we want to do? Make the products, which we've done. So 2.1 is done. We've got diamond, crown jewels, and silver locket. Created the shop. Now we want to put 125 gold coins in its coin box. And as I said before, because it's going to be useful later to have this add gold coin method, we're actually going to do this inside the main, or I'm going to choose to do it inside the main rather than inside the shop class itself. So we're going to say I is less than 125. Again, I'm just capitalizing on the presence of these methods. So the process is very, very similar as for the filling the chest, except of course, this, as I say, I'm doing it inside the main this time because I'm capitalizing on this add gold coin method, which will be used for elsewhere. Same process, I'm going to make this kind of class copy, not store it temporarily inside an object. I could say gold coin, coin equals new gold coin. And kind of each time I came around the loop, this would be filled with a new class copy. This would be a new different object each time, because every time I write new, I get a new class copy. Store it, becomes an object. Again, what's actually going on here, the fact that I can't emphasize this enough, the fact that I'm doing new gold coin here shows that there's more subtleties to objects in memory, which again, you'll see next semester. But for now, we keep things nice and simple. We think about this actually being, we're creating the class copy here and passing it to the shop. But of course, this is really the object, wink wink, as we know, and we'll see next semester. So we put 125 coins in the shop's coin box, like it's float. So it's stuff that shops use to, it's quite a big float, to give change to people. They put some of their own money in the till. That's what the idea is here. Add the products from the previous question, which we've done. Print the shop's details to the terminal, including its name and the number of coins in its coin box. So we want to print the shop's name. So we're going to say, I don't think we're going to use our toString method here, which again shows when we should and shouldn't use the toString method. So we've been told that the toString method should include the shop's name, haven't we? Yes, so 1.6. which presents the name of the shop and all the details currently in stock. Okay, so I know that my toString method, every time I call it, is going to include the shop's name and what's in stock. But here I'm being asked for the shop's name and the number of coins. Oh, I am being asked for the products, aren't I? I am being asked for the products. That's actually fine. Yeah, ignore me. So it's fine here to use the shop directly because we want its name and its products. But of course, again, at a similar point in terms of the flexibility of toString, but kind of from a different perspective. Here I don't have the coins inside the toString method which are shop, right? Because it's kind of not something that I want to see every time I print the shop object. It's kind of, I guess, a bit private information to the shop. So it maybe didn't make too much sense to put it inside the toString. So again, limitations of toString, if we leave something out, we need these separate get methods, don't we? And which actually isn't always a limitation. It provides us with more flexibility. So here I'm going to get the number of gold coins in the shop. So this talks about yet another accessor method. Lots of ways to do this, but I'm just going to return an int here. So get number of gold coins. I'm going to return coins.size. Yeah. What was it called? Coinbox. Sorry, coinbox.size. Remember again, we used .length for arrays, which was kind of like a public final field in a way, a kind of virtual public final field for the arrays. So we did something like .length, didn't we? Here, because remember array lists are classes, there's a method here called size. So don't make that mistake. Remember that distinction: length for array lists. For arrays, size for array lists. You see, even I mix them up sometimes. So we want to print the shop's details, which includes the coin box, the products, and the name. So we have that already from our nice toString method, and we're going to say shop.get number of gold coins. All right, so that's 2.2 done. So it's great. So create a customer, which I've done. Call him Blackbeard. No, I'm going to call him Martin. I'm going to call him Chatbeard. Actually, love it. And then give them 100 gold coins. Very similar process as before. Just this nice for loop. It's going to go through, give Chatbeard all these coins. So martin.addCoin. Again, different method name here just to make it clear what's being added where for you. And then that's that. Print their details. So we want to do system.out.println. This is hinting that we want to see the details that we've just shown. So we're going to say what's martin.getName. And we want to see the number of gold coins in their purse, which we may or may not have already done. Did we do that? No, we didn't. So we want public void int coins in purse. Again, this is just nice practice with how to use collections, especially here. This is kind of getting you to work with size, I guess, and how you'd use that. So purse.size, which is nice. Remember size over the use of .length here. So we can say martin.coins in purse. Yeah. Again, a little bit, I suppose, tedious to do this printing, but just good to kind of get to grips with, exactly what's printed where, for the reasons of looking at, as I've said, the benefits and drawbacks, the flexibility of toString, and when you might want to use get methods instead, or when you might need to use get methods instead. And of course the use of size as well. Right, so I think that's all the preliminary printing done. So now we go on to our main loop. So an introductory message to the user. Going to be very simple here. Welcome. Okay, that's good. And now we want to repeatedly present the products in the shopping basket and the total number of coins in the customer's wallet to the user. All right, so we're going to need, again, we've looked at user input loads of times. It was like in CW7, it's again in CW9. The process is the same. You can do things in different ways. I typically go for the do while. So I'm going to say, obviously, I'm going to need a scanner. Should be very, very familiar now. I think if you're, I'm going to go fairly quickly through this. But if you want to look at scanner, I think it's CW5 or CW6 with the rooms was the first time we looked at this in real detail. Going to go for a do while. I like my do whiles. So first I'm going to say input like this. Again, I'm using lots of do whiles, but a while is perfectly fine. I know we only talked about do while very briefly in the lectures. And until they say exit, so we want to loop while it's not the case, or we'll do the positive case first. This is equal to exit. Then we want to keep looping, right? So again, I talked about the do whiles in CW7 video. Take a look at that and see what we think. Thank you for that, Alexa. Okay, so it's going to show us an error for now. Sorry, as you know, Alexa likes to chime in She might be able to hear. She likes to chime in on my videos. Okay, so we get an error for now, but we'll come back later on, and you'll see that this won't be a problem in a second. So we want to repeatedly present the products in the shop, the shopping basket, and the total number of coins in the wallet to the user. Okay, so we want to say what's in the shop, like this, and then shop. And we want to say customer's basket, like this. Okay, so then inside customer, again, a little bit of flexibility here in terms of how you do this. We might want to add maybe just a toString method here as well. I'm not going to actually. I'm going to say something like just going to do a simple accessor method that gets me the get customer basket, because I think to make this a toString method maybe ties us down a little bit to what we want to do. So get shopping basket like this. Again, lots of different answers, lots of ways to do this. So we're going to say customer.get, what did I do here? Get shopping basket, right? So I think it's not going to show me the autocomplete because it's not happy with this. And then just to keep Java happy, we're going to say in.nextLine. Okay. Oh, of course, he's called Martin, isn't he? Martin.get shopping basket. Okay, so we say what's in the shop, products in the shop, the shopping basket, and the total number of coins in the customer's wallet. So we could say customer's basket. We could say customer's wallet. And again, remember we had this did this method before, so we can say Martin.coins in purse. You see what I mean? Again, could think about combining these two things. But again, as you can see here, so we had Martin.get name, Martin. So let's look at the places we've interacted with customer. So we got the customer's name and the coins in purse, and then here we got the shopping basket and the coins in purse. So what would we put in the toString? We could put the name and the coins and the purse in the toString, but then later down here we'd still have to interact with things individually. We could put the basket and the coins in purse in the toString. Not really right to print the customer's name each time they're around the loop, I don't think. But then here we could, if we did the toString here, then we'd get an empty basket, which again doesn't feel quite right. So again, flexibility here, but I think I'm just going to stick with these individual accessor methods here, just to emphasize the difference between, toString is this one size fits all. For a class, typically we always want to access the same information from a class. So like a shop, we always basically want to see the same things. With a customer, we often want to see different things, so it's nice to have the flexibility of these different accessor methods here. Okay, that should be fine now. Let's test what we've got. So if I do exit, am I going to end? Yes, I am. If I do anything else, am I going to keep going? Yes, I am. Excellent. Okay, and let's do leave myself a bit of a gap here. Right. There we go. Here we are. So if the user enters add product, they should be prompted to input the name of a product from the shop's product list, which should then be added to their shopping basket. This product must also be removed from the shop's products. So remember we had this idea that there's a difference between what's on the shelf and what's in my basket. If I take it off the shelf, if I take a can of beans off the shelf and put it in my basket, that can of beans is no longer on the shelf, right? So it's this idea that we want to remove products from the shop once they've been put into the basket. So we're going to say, I'm not going to do any fancy output. I'm sure I saw loads of people doing really nice stuff. I'm not going to. I'm going to say if input.equals add product. Yeah, so I'm just following the brief here. And we're going to prompt for more input. So we're going to say input equals in.nextLine. Remember, every time you call next line, it's another round of input, which does have an impact on if statements, things like that. Always remember that. And this should then be added to the shopping basket. So how do we do that? Well, we got a string here, and we want to get a product back, don't we? So we need to actually search for that product like we did with the island, right? So that when you prompted the pirate to go to an island, you transformed a string into the object that was represented by that string. So we need to say shop.search product input. Yeah, so if the result of this is either going to be null or it's going to be a product object, isn't it? So exactly the same process as CW7. We need to say if this is not equal to null. So if we don't get a null value back from this, then we know that we've actually got a nice product object here. So we can say customer, oh, I keep thinking it's called customer, but it's called Martin, dot add to shopping basket, and we can do the search again. Okay, so again, people might like temporary variables here to store things. Again, it's just my preference to do this search again. So and remember, we only need to use, and we saw this again in CW7, so I'd say go back and look at this in detail if what I'm about to say doesn't make sense. But if the result of a method actually mutates some element of state in that class, so for example, we saw get 1 gold coin actually changed that coin once we'd called get 1 gold coin inside pirate in CW7, we saw that that coin had gone. So we had no choice but to use temporary variables, right? Because we couldn't say if get 1 gold coin is not equal to null, get 1 gold coin, because the coin you test first is gone once you've called that method, right? So you can only call it once and store the result in a temporary variable. Here, because there's no real change to state, and again there wasn't in CW7 either when we were searching for islands, we can happily do this twice. We can see inside shop there's nothing's changed by searching for product. I can search for product multiple times, it's not going to have any effect. Whereas doing removals and things like that and testing the result will require a temporary variable, but not the case here. Okay. Otherwise, so if they've entered something crazy like, I don't know, ham, pirate shop, then we can do something like system.out.println product not found. Yeah? So then there's the other step, isn't there? So remember it says in 4.3, I think it is now, the third bullet point, we need to remove it from the shop, right? So we need to say shop.remove product, and then again we can go ahead and we can search now, but we don't search in the shop, do we? Because that product will no longer be in the shop. We say Martin.search shopping basket for the import. Does that make sense? So we take the product from the shop. Well, effectively, we take that object and we add it to the Martin shopping basket. And then we look inside Martin's shopping basket and then remove it. Actually, shop would work too, right? That would work too, because we've not actually removed it yet. So this could be shop.search product, actually, couldn't it? Because you see, we've not actually removed it yet. That would work, but I think it feels neater to do it. At least to me, it feels neater the other way. It feels easier to read. So we search for the product in the shop, effectively add it to Martin's basket. Then we look for it in Martin's basket and then remove it from the shop. Okay, so almost definitely done something wrong, but let's see what we have. Okay, so what's in the shop? Diamond crown jewels and silver locket. Apologies for that flowing off the screen there. So we're going to say add product. Yes, also, well, so if I would say diamond. Okay, so what's in the shop? Crown jewels and silver lockets. The diamond's gone, and brilliant, it's in my basket. Whew. Okay, so diamond has now been taken from the basket. From the shop and put in the basket, which makes sense because if I take the diamond off the shelf, and in this case there's only one diamond in the shop, it's gone. So I'd encourage you to see what happens if you put multiple products in. You'll see that I only take the first instance of that product, which makes sense because if there are 2 diamonds on the shelf, I put one in my basket, there's still one left on the shelf for people to buy. So I'd encourage you to play with that. But of course, for simplicity, we've only got one product of each type, so to speak, because of course they're all of the same type, really, of type product, but you see what I mean in the shop in this way. Okay, remove product, very, very similar. So else if input dot equals remove product, then input equals in dot next line. Say if, again, very, very similar. We need to translate it to a product to remove, don't we? Because if we do, at least if I'm correct, so input the name of the product that they wish to remove from their shopping basket, and then it should be removed from the shopping basket and added back into the shop's products, right? So it's the reverse process here. So customer for remove product does indeed require a product object. So we can say if, again, because it's only going to be inside the Martin's basket now, if search shopping basket input not equal to null, so if it exists, then we're going to say the opposite way around. We're going to say shop dot add product, and we're going to say Martin again dot search shopping basket input, and then the other way around we're going to say Martin dot remove from shopping basket, and then we're going to say shop dot search. There's a real nice symmetry to this. All right, so we can test it now and see what's going on. Let's see what we do. Else we say item not in basket. Yeah. Okay, let's see what happens. So if I want to do add product, yeah, I want diamond. Great, so diamond's in basket. If I do first of all, let's see what happens if I do blue. Just gets ignored. That's good. Back to the top of the list. Now if I say add product, and then say blue, product not found, back to the top of the list. Diamond's still there. That's good. Now what happens if I say remove product? Yeah. Then I say diamond. It goes back to the shop, and the basket is empty. Great. See what's happening there? You see it's nice here to see that it actually gets added to the end of the list. So you'll see that you can kind of understand a bit more about how these lists move and shrink and resize and where things get added for these different data structures, which is of course the whole point of this assignment, to look at these structures. All right, things are looking good. Let's look at the final case, right? So else if import dot equals purchase. So again, we're on to now 4 point, not 1, 2, 3, 4. So if the user enters, 5, if the user enters purchase, all the products in the shopping basket must be purchased. So we say purchase. And what we want to do now is effectively just say customer dot purchase. Again, I keep doing this, don't I? Martin dot purchase. Remember this method that we wrote before? Inside purchase, just this skeleton method that I read before, takes a shop and that I'm about to complete, and we pass it a shop, and that's it. Okay, good. Ugh, user input stresses me out. Good. And then in any other case, we'll just keep going back around the loop. Okay. Again, you probably did nicer things here. I've done the bare bones here, but it's just to check that everything's working. You probably did some nice error message and stuff like that, especially if, for example, the purchase fails. So you could say, if not, this fails, then system.println. Actually, let's just do this. Purchase failed. Otherwise, system.println. Purchase successful. Yeah? Okay, good. So before we test this again, let's now implement our purchase method, which I'm referencing here, just this kind of method that I'm waiting to complete inside shop. And again, this is the crescendo, the crux of the video. So what are the steps for a purchase? Let's go back up, scroll back up to 1.7, I think. Yeah, 1.7. Lastly, for customer, it can purchase products, which takes a supplied shop, which I've done, and purchases the items that's currently in the shopping basket. This returns either a positive or negative result to indicate whether the transaction went through successfully. So I've got my Boolean ready for me. And this works as follows. So the total cost of the shopping basket is calculated. Let's do it step by step. How do I do that? Well, let's look at a temporary variable. So I'm going to be working with the shopping basket list, aren't I? Which is going to be full of products. So I want to go through this list. Let's look at everything in the shopping basket, don't I? So I'm kind of taking the items out, looking at the little price tag, the piracy little string price tag that's kind of tied to it that says a certain amount of gold coins for it. So I might look at one wrapped around the diamond, bit of string, bit of cardboard, says a price. Might look at that, put the diamond back in my basket, pick out the crown jewels, look at whatever's on that, the 100 that's attributed to that. So effectively I'm looking at each product and I want to read what the price is, don't I? I want to read the price on that product so that I can work out the total cost. So that means the inside product, I'm going to need another nice little get method. Again, as the assignments as you get further along in the course, you'll be used to using these get methods, so you can add them as you wish, so long as it doesn't violate any rules of the assignment, which will be stated. In this case, there aren't any, so we're able to do this. And again, this shows you the difference between the gets and the toString, right? So toString was nice just for visual purposes. If I really want to drill down and get these individual values out, I need the kind of granularity that's offered to me by get statements. All right, so get statements aren't redundant in the event of toString, they serve different purposes. So here I want to calculate, I'm still just calculating the total of the cost of the items in my basket. So I go through that basket and I say I want to add onto total cost the cost of each product, right? So product.get price. Okay, so eventually this is now going to give me the total cost of all the items in my basket. Okay, and now what I actually want to do to make kind of expedite testing here, shall we comment this out for now? Because I realise I don't really want to keep going around this loop to test things, and let's kind of make things a bit more stylized. So let's say I'm going to say everything's in the shop, right? So I'm going to say Martin dot essentially say that the diamond isn't. Let's actually say that the crown jewels aren't in the shop, but instead they're in Martin's basket. Okay, so you see what I'm doing here? I'm just skipping ahead rather than doing this through user input, which is going to become a headache. I'm going to do it manually. So manually, the crown jewels, we might imagine that they were in the shop, but then the customer came and put them in his basket. So I'm doing this manually rather than through the loop, which would get tedious. Then I'm going to say shop dot purchase. Sorry, customer Martin dot purchase, and I'm going to use the shop like this. Okay, so I'm going to do this manual purchasing. Alright, so we're going to see what happens here. So customer, let's do a little print statement to see what we've got. System.out.println total cost, like this. Let's see what happens. Okay, so total cost, just to let us know what this is. Again, nice to have these annotated print statements to see what's going on. Total cost is 100. Okay, so I know that I have one item in the shopping basket. Let's just print this for clarity. System.out.println Martin.get shopping basket. So I know I have one item in the shopping basket here. See the crown jewels. I know it's a price 100. So I can see this like this. That was very vague, wasn't it? So I can see what's in the shopping basket. Total cost is 100. So now if this cost is higher than the amount of coins in the customer's purse, the purchase should fail, right? Because if I don't have enough coins to buy the total cost, then I can't proceed with the transaction, right? So it's like I put everything in my basket on Amazon, but I get to the checkout and I've only got £5 in my account. Sounds very familiar. So you see what I mean? So we need to test the total coins compared to the total cost. Yeah. So we say if total cost is higher than the number of coins I have, right? So we're not working with actual because a coin is equal to 1 basically. That's what we're saying here. Everything is in units of gold coins. Yeah, so there's 1 gold coin. So if something costs 100 gold coins, that means I need 100 gold coins to buy it. So if if I only had 50 gold coins in my purse and the total cost of the items was greater than that, then it would fail. Okay, so here we're going to say return false, right? Because that indicates that the purchase has failed. So I'm going to say else return true. Yeah, so if the purchase, if I don't have enough money to buy all the products in the basket, then that's going to be indicated by the total cost being greater than the purse size, in which case I'm going to return false. Otherwise, I'm going to return true. So we can test this by giving our Chatbeard some more items. So let's give him the silver locket too, so that's now no longer in the shop. Again, I'm just doing this manually if this is confusing. This isn't part of the final program, this is just me skipping having to do everything through the loop, which would become tedious. It's something I recommend you guys do too. So here you can see in shopping basket, crown jewels, silver lockets, that's 160 in total, but I know that Chatbeard only has 100, so what happens if he tries to purchase it? What's the value, what's the result of the purchase going to be? Result of purchase here is, I think, going to be false, okay, because I don't have enough money. But if we were to manually take the locket out of Chatbeard's basket and put it back in here, just doing the crown jewels, true. Okay, so that's what I mean. So he's now able to buy things if they're in his price range. Okay, here we go. Here's the tough bit. So the required number of coins are transferred one by one from the customer's purse to the shop's coin box. Okay, so let's try and build the most natural solution here. We're going to need a for loop, aren't we? Because we want to go through the customer's purse up until the amount they want to spend, and then transfer the coins from the purse to the coin box. Okay, so a nice for loop, int I equals 0. We could say int coin equals 0. Coin is less than total cost. So we'll go from, if it was say 100, we'd go from 0 to 99. So that's 100, which is nice. We want to take out 100 gold coins. Yeah, so this is we're not really relying on the indices directly here. We're using this to work out how many coins we want to take from the pirate's purse and put into the shop, basically. Okay, so we say coin plus plus, and then we could say, well, what do we want to say? We want to say coin, so we want to say the purse, yeah, dot get coin, don't we? Want to get the 0th coin and the first coin and the second coin, third coin, etc., etc. We want to get that out of the purse, and we want to add it to the shop, don't we? So we want to say add gold coins. We want to take each coin object in turn, 100 times, however many times it is, whatever the cost of these items are. We want to take it out that many times and add it to the purse. But of course I've been doing this in the wrong place because that's return false. Okay, that's if we don't have enough coins. Here we know we do have enough coins, don't we? So we want to take this many, equal to the number of total cost, we want to take this many coins and put it into the pirates, put it into the shop. Okay, so we get a gold coin here and we put it into the shop. Okay, we don't want to get, do we? We want to remove. See, so we're already evolving our solution here. So you can see it's not just get, is it? It's remove. So we want to actually take the gold coin. So here you can see remove is a bit versatile, right? So remove has 2 forms in the API. It's got a different return type here, which is nice. Okay, so if you give it an integer, yeah, we will talk about this next time, but it should be clear we've kind of hinted at it already, this idea of method overloading. If you give remove in the ArrayList class an integer, it will return you an object at that index. Okay, this contrasts inside shop, for example, where we removed a product and we gave remove an object, in which case it gave us a Boolean. Okay, so it's a method with the same name that acts in different ways depending on the parameters it's given. So this is method overloading, something that we've hinted at already with the use of multiple constructors, and something that we'll review again briefly next lecture, before the revision lecture. So here you can see if you give it an object, it will return you a Boolean, which makes sense because it confirms whether that object has been removed or not, because it either existed in the list or not. And if you give it an integer, it's going to remove you an actual object, which is nice. So we're saying I want to take the 0th coin and add it to the shop's coin box. Okay, see what happens. What's going on? Okay, so what happens here, like this was intentional, is let's think about it. So what I'm doing is I'm going from 0 to 100, right? Because I know I want to buy the crown jewels. That's why in the shopping basket they're worth 100. So the top value of my loop here is going to be 100. This is going to go 0, 1, 2, 3, 4, 5, 6. But you see what's happening here is I'm removing from the 0th index, then from the first index, then the second index. So as I remove it, remember the way that an array list operates, the array list shrinks, right? So at first I would have the 99th index, I'd kind of have the 99th index available, but then it kind of vanishes, right? Doesn't it? Because you see, the size of my my array is getting smaller. So you can see every time I go around this loop, I could do system.println pers.size, right? Sues pers.size like this. I can see it's getting smaller, right? So here we can go around the list. You can see, look, size is getting smaller. It gets down to 50. So let's try and do this in even more detail. Let's say, and this is something I'd really recommend you guys do, trying to access index coin and per size size is like this, and we can see this in even more detail, right? We can say, look, trying to access index 49 and size is 50. You see, so that's fine. That's the last one. That's fine. But here you can see they'll be trying to access size 50. Actually, let's do it before. So we can actually see the final thing that's the nail in the coffin. You see, trying to access size 50, it's index 50, but size is 50. You see what I mean? So we were planning, our grand plan was to loop from 0 to 100 and to extract the coins at each of these indices, right? We wanted to go from the beginning of the purse to the end of the purse in this case, so up until 100, and remove each coin with this idea at the beginning that there was going to be these 100 coins there. But of course, that's not the case, right? We can't now reach that index because it no longer exists. That makes sense? So really, because as we're kind of going up through 1, then things are shuffling down. So you could almost think about something, everything moves backwards 1. So I'm at index 1, and then everything now index 0 is filled. Everything moves down, doesn't it? So it's like I'm kind of scrambling up a mountain that's slowly falling out from underneath me, right? So it's kind of falling back down to the bottom of the list. So by the time I'm at index 3, the coins that I really want, I'm pointing with my finger here as if you guys can see this, the things that I really want when I'm at index 3, the extra coins that I want are now at 2, 1, 0, right? Because everything shuffles down. So I don't really want to move forward through the list. That wouldn't make sense. And again, if I get to 10, then because everything's been shuffled down, what I thought I was able to grab from the end of the list has now come to the beginning. It's kind of filled 0, 1, 2, 3, 4, 5. It's filled everything behind me as I'm kind of scrambling up this list as it gets smaller and smaller and everything shuffles down behind me, so to speak, as I'm going through the list in this way. I don't want that, do I? I can't do that. There's a simple fix, which is to actually, and there's lots of different fixes. You could go backwards through the loop, for example. That would be an option. You could do backwards indices. I believe anyway. Haven't tested it out. It's something for you to try. But I believe the simplest thing, the simplest way we can do it, at least the way I did it originally in my mind when I saw this assignment, was to do purse.size -1. So we're always going to extract from the end of this. Sorry, purse.remove. And the index we want to remove from doesn't actually rely on coin, it actually just relies on the size of the list. Okay, so what we do is we take the coin index out of the equation altogether. This now just becomes kind of nominal. It's here just to move the loop up this 100 or however many times we want according to total cost. So you could maybe use a while loop here if you think that's a bit more readable, but I'll leave it as a for loop for now. So here now coin is redundant. You see we don't use it inside the list anyway, so we don't run this risk of relying or trying to access indices that no longer exist. Okay, so effectively we're now taking the coins from the back, but also now we're not relying on an index here, so there's no chance of trying to access these indices that don't exist, and you see now everything's fine. Okay, does that make sense? So I'd encourage you to watch that again, write this out, do print statements, see why that didn't work. See this idea of the indices falling away from these items that I want to get are now actually shuffled down behind me as I go up through the list. So the solution is to instead take from the back of the list and kind of use this coin as a nominal value that isn't actually used. All right, so we can go back to, hopefully that makes sense. We can go back here and now see what's the state of the shop after I've done my purchase. System.out.println, money in Martin. We can say Martin.coins in purse, and we can say money in shop, and we can say shop.get number of gold coins, so we can see what's gone on after this purchase. Okay, you see now Martin is 0 because he spent all his money on the crown jewels, and now we can see the money in the shop is 225. Okay, so we can see this transfer is working. We can see that we've taken each coin one by one from the end of the list. As it shrinks, we kind of shrink with it, so to speak, from the back, which is nice. Of course, another choice would be, I think, again, it's not something I tested out, but I saw some people doing this, which was nice, to always go from 0. I think that would work as well. Again, not tested, something for you to try out there, but kind of intuitively, I think that would be the same, as long as we kind of take from this one fixed place. I think it's nice to kind of take from the end of the purse, and it's kind of a principle we saw with extracting from the chest anyway, so it's nice to evolve our understanding of the assignments in that way. So you can see Martin's, originally, the shop had 125, didn't it? We saw it up here, so he gains, Martin pays £100 for 100 gold coins, for the crown jewels. So he ends up with nothing, and the shop ends up with 125. The products in the shopping basket are transferred to the user's owned products, and then the shopping basket is emptied. Okay, so let's make a purposeful mistake again. So let's say for product in shopping basket. Let's say owned products. In fact, let's use our method here. Why not? Sometimes it's nice to do this, just for readability. We want to say, maybe we want to add product like that, don't we? Because we want to add that to the wait, what's going on here? Add owned product. Sorry, add owned product, and then maybe we wanted to say something like shopping basket dot remove product. Something like that, right? Yeah, seems all right. I think, yeah, concurrent modification exception. So this, again, something that Asad talked about in topic 8. We talked about this idea that you can't change a list while you're iterating through it, which makes sense because you can't really, again, I guess it's a similar principle to the gold coins, but enforced a bit more strictly. You can't iterate through something while you're changing it. Doesn't make sense, right? Because things might disappear, arbitrarily. So Java throws you this exception to stops you doing it and ending up in these difficult situations where you plan to loop through something and then it no longer exists. Okay, so you get this idea of a concurrent modification exception. So it took me a long time to realize, why people ask me about iterators. So iterators solve this problem. They do indeed, but they're not part of the PPA syllabus, and there are actually more elegant ways to solve it. I think iterators are a bit of a brute force approach here. So one way to do it is to actually make a brand new. This is actually the way I would do it if I wanted to solve it and I had no other option. So this is kind of the hacky approach. So you can make a brand new copy of your array list here and iterate through that rather than the original copy. Okay, this is a bit hacky. I mean, you'll see if you look at the array list API entry, you'll see there's an option to supply an existing list and make a brand new object that isn't actually it's now a completely separate list. So you don't get this issue. That's a bit hacky. Again, I think iterators are a bit brute force. So there's almost always a nice elegant way to alter your program to avoid these concurrent modification exceptions. And in this case, it's to realize, well, we don't really need to remove in the loop itself, do we? I can actually just clear from the basket after it's over, right? So again, head to the API, think, well, I've got this idea that why do I need to remove items from my basket one by one? Can't I just kind of erase what's in my basket? I can. I could just do, if I can spell it right, shopping basket. I can just do this .clear method, and now what this nicely avoids is me having to change a loop while going through it, which of course Java doesn't let you, because you don't want to be able to change the goalpost. So it was fine here, right, because we weren't really predicating the loop on the size of the purse. Had we been, we would have run into a similar issue, but here before, when we tried to change the shopping basket inside the shopping basket loop, we were actually trying to change the loop we were inside. Makes sense? So again, the kind of brute force approach is iterators, which, I mean, I don't typically use because I think the for each loop has enough expressivity there. If you desperately had to do a concurrent modification to avoid the introduction of this heavy iterator approach, I would do this kind of new array list thing. A little bit hacky, but I think it's perhaps a bit nicer than kind of bringing in iterators onto the scene. But of course, as always, in these cases, it's just about reshuffling your logic. Okay, so you can almost always avoid these concurrent modification exceptions by reshuffling your logic here. Not always, but lots of the time you can. Yeah, so here the idea was that we avoid that in that way. I think I'm done on my days. I think I'm done. The customer's total overall spend in the shop is then updated with the total taken. One final step, one final hurdle, which lots of people considered. Okay, so my encore, shall we say? This is my encore to this video. So the customer total spend, everything's happy. The customer's total spend in the shop is then updated with the spend undertaken in this transaction. Okay, so the final step is to say shop.update total spend, and I now want to pass my total spend, right? Because that's the new amount this customer has spent. Problem. I want to talk about a customer, don't I? But which customer? Which customer am I talking to? There's no customer passed through this shop, right? What I really want to do is I want to talk about this customer here, this object, the object of this instance that I'm currently operating with, don't I? Because the customer that's done the purchase, that's doing the purchasing in the shop, is the customer that's represented by the current object of this class. So in this case, it's the Martin object, right? So it's the Martin object that you're calling purchase products on. So it's the Martin object that's having its purse emptied. It's the Martin object that's making this purchase in the shop. So really inside the list of transactions inside the shop, I want to kind of pass the Martin object, take Martin's name, and then attribute it to this spend inside the shop in this way. How do I do that? So I saw lots of people racking their brains about this. The answer is very, very simple. So we talked right at the beginning about the use of the word this, right? And how this refers to the current object, doesn't it? So this is the reason that this syntax works, the reason that we're able to differentiate between fields and local variables or parameters here, because the fields exist within the object, right? Whereas the local parameters exist within the method. So I'm saying go to this object and get the name associated with this object. I can do this even more abstractly. I can just reference this. I can reference this object. I can talk about the current object that we're in right now, which is exactly what I want to do here, right? So I can just write this. Okay, so I can just write this, and if this was against the right word, it would work. So total cost. Okay. So if I want to reference the current, again, as I'll say, if I want to reference the current object, if I want to pass an instance of myself, of the class that's currently existing as an object, I use the keyword this. So what I do, I can refer to this object, the object of this class that's currently having this method invoked on it, which is purchase products, and then I pass it through in that way. Okay, so shall we go to shop now and then add our cheeky toString method back in that returns customer total spend, just to finally check, and then we'll have to manually call toString here. Another idea actually just to show you would be just to concatenate it, because remember if you concatenate an object to a string, it'll be transformed to its default representation. So then inside shopping trip now, I can say system.out.println shop, and I should have a record of Chatbeard spending £100 on his crown jewels. It's a little bit odd, but you get what I mean. Does that make sense? So this is the process now. I want to purchase, so I call Martin and purchase products, passing in the shop. If I could go in the right class, I first calculate the total cost in the basket. If it's more than I can afford, then just end early, return false. Otherwise, I proceed with removing the coins from the purse. I do so from the back, in a way, so I can avoid interacting with the changing index. Again, review that section of the video if you need to. I then avoid changing a loop inside another loop, which was a nice thing to test here. This current concurrent modification issue, again, very well designed piece of work from Assad there, trying to test you on this concurrent modification. I then clear the basket here to have this more elegant solution than the need for an iterator or a new array in that way. And then finally, for the encore, we interact with the keyword this. Again, a well-designed piece of work to have you look at this, so to speak. You grab this current object and you can pass it around the program in this way, and we get this expected output. Okay. One final run of the program before I leave you. So everything should be in place now. So let's run it. So the first thing I do is I want to add product, right? Add product. I want to purchase. I want to add a diamond. Oh, remember, okay, so a nice thing to do here is for you to come back and make it case insensitive. So now there's product in my basket. Why is there nothing in the shop? Oh, because I took some products out before, didn't I? Here we go. Oh, and my two-string method. Okay, here we go. Alright, take two. So it's live TV, folks. Alright, here we go. So now everything's is more rosy. Add product. I want to buy a diamond. Great, diamond's now in my basket and not in the shop. Add product. I want to buy the crown jewels. Now the crown jewels in my basket, okay. Now I want to purchase. Purchase failed because I had too much stuff in. I don't have enough money. I'm you know, my eyes are bigger than my wallet, so I need to take something out, don't I? So I say remove product. Crown jewels. I realise they're too expensive. It's not worth it. Don't look good in jewelry anyway. So now all I've got in my basket is my diamond. So I purchase. Excellent. So I could print the things that are in my possession. That would show me then, but I'm just going to trust that. Well, I know that's going to be fine. So I say silver locket here. That's what's left in the shop along with the crown jewels. My basket is now empty, and I've taken 40 out of my coins because that's how much I paid for my wonderful diamond. All right. So as always, things that I can go around and make more elegant, different ways to do things. Let me know what you think. Engage, ask questions, and talk to me about what's gone on here. Any different ways that you did things, let me know, and we can chat about it. But otherwise, hopefully that's useful feedback. Go through it, write it out, use it for revision, use it as necessary. Thank you very much.